Example number 7. I already put in the matrix form. And you can see that normally we have this location to be 1 first at the beginning. But in this situation, we do not have. And we want to switch for the other row. We still don't have a 1 over there. So we need to make this. I noticed that we can combine some row 1 and row 2 to do it, or row 1 and row 3. So I noticed that 6 minus 5 is 1. So what I'm going to do is I will make row 1 become 1 at that location by doing row number 1 subtract row number 2. Then I will get 1, negative 2, 0, and 1. And then we copy out the rest. And then we will use that 1 to do this location to be 0. We will multiply by the opposite. So for the row number 1, we multiply by positive 12. So 12 of row 1, and then add row 2. And put the answer in row 2. And to do 5, 0, we need to multiply by negative 5 row 1, and then add row 3. And we put the result in row 3. So we show the work. So we can get that 12 times row 1, we will get 12, negative 24, 0, and 12. And then we put row number 2, negative 12, 2, 2, negative 8. Add them up. So we have 0, negative 22, 2, and 4. For row number 3, we multiply by negative 5 for row 1. So negative 5, 10, 0, negative 5. We put down row 3. And then we add them up. So we get 11, negative 1, negative 2. So then we will have 1, negative 2, 0, and 1. Row 2 becomes 0, negative 22, 2, and 4, 0, 11, negative 1, and negative 2. Okay, so we finished the first column. Now the second column, we want 1 and 0. So 1 right here and 0 right here. So to make 1, we think about the x and y form. So this is mean negative 22y plus 2z equal to 4. To make 1, we will divide both sides of the equation by negative 22, or multiply by 1 over negative 22. So row 2 equal negative 1 over 22 row 2. So I just divide all of the number by 11, right? Okay, and then we will make this location to be 0. We will use 1 right here. We will multiply row 2 by negative 11, and then add row 3, and we put the result in row 3. So we will get 0, negative 11, 1, and 2, and then 0, 11, negative 1, negative 2. We add them up, we have 0, 0, 0, and 0. So negative 1, negative 2, 0, and 1, 0, 1, negative 1 over 11, the same for this row. And the row number 3, we get 0, 0, 0. So you notice that we have 0, 0, 0 for the last column, for the last row. And if you think about the x and the y, so 0x plus 0y plus 0z equal to 0. That means 0 equal to 0. We got the true statement. So in this case, we have infinitely many solutions. So how do we write down our answer? Let's convert back into the xy form. So we have, right here is a positive 1. Okay, so 1x minus 2y equal 1. Y minus 1 over 11z equal to negative 2 over 11. So we have these two equations. We can convert everything in terms of, we solve for x and y and in terms of z, okay? So in the bottom, we solve for y, we add 1 over 11z both sides. And then to solve for x, we get 1 plus 2y, okay? Now I can plug in the y so that I have it in terms of the z. So x equal 1 plus 2 times 1 over 11z minus 2 over 11. So distribute. And combine the 4 over 11 and the 1. So we get 2 over 11z plus 7 over 11. We add the fraction. We combine 1 and 4 over 11 together. So y equal 1 over 11z minus 2 over 11. So the answer would be the set of x, y, z such that x equal 2 over 11z plus 7 over 11, y equal 1 over 11z minus 2 over 11, and z is any real number.